Hey everybody, it's Grace here, and today we are on lesson 7. And in today's lesson, we're going to be learning how to calculate areas. So let's go ahead and get started. So let's first write a program that calculates the area of a circle given its radius. So if you haven't already, open up Replit in another tab. And we're going to go ahead and create a new program to write in for this lesson. All right, so first let's think about what this problem wants. So we're going to be given some radius, and then we want to calculate the area of a circle given that radius. So that means for the input, we'll want to read in the radius. So here, I'm just going to set up my scanner so that I can read input. And now I'm going to create a variable to store the the radius. And I'm going to let this be an integer type. Now, of course, you can also let it be a double if you want the radius to also be decimal numbers. But let's stick with integers first for now. So I'm just going to call it radius, or you can call it r, as people usually say in math. And here I'm reading in the next integer. Okay, so now I want to figure out how to calculate the area of a circle. Well, if you are familiar with circles and you've studied a bit of geometry, you'll know that the area of a circle is equal to pi r squared. So we know the mathematical formula, and basically what we want to do is translate that into our program. So our area here, we can take two approaches. One is where we print out the part that doesn't include pi and then the pi symbol, or we can print out the total value of pi times r squared. So let's try the first approach first. And here my area would simply be an integer. And this is going to be equal to r squared. So just radius times radius. And that means that when I print out my output, I will print out the area number and then add on the pi symbol. So you can find that online, copy paste it, but here I'm just going to say pi, literally. Now let's run this and test it. So let's say that I have a circle with radius 5. And so for my output, I get 25 pi. And this would be correct if you don't directly multiply the r squared portion by pi. Now, let's talk about how to do it if we want the total value, including where we multiply r squared by pi. So for this, we're going to want to convert our area to a double, because if you guys do not know, pi is a decimal value. So pi is about 3.14159, I believe, and so on. So as you can see, r squared is going to be an integer value, but pi itself isn't. So the area has to be a decimal value. So we store it in a double type. Now here, radius times radius remains the same. However, now we want to multiply the integer part by pi. So there are two ways to go about this. One is you can kind of just take the first few decimal places of pi and literally stick it in there. Now, this isn't as precise, and so there's a more precise way to do this. We're going to use the math library, and there is a math.pi here, and this is the exact value of pi. So as you can see, if I hover over this, it shows the value that has a lot more decimal places, so be a lot more exact for our result. So now when we print this out, we just got to print out the area. We don't need to print out the string pi. So let's run this now. So using my same example, if I have a radius of 5, then this is the approximate area I get. And so you can check that. 25 times pi, 78.539, so on. So this seems pretty correct. Also, one thing, if you haven't noticed, is that in Java, if we have a double type, we tend to get a lot of decimal points, and sometimes that could be helpful if we want a precise answer, but other times it doesn't look so nice to read. So here we're going to use a little bit of string formatting to sort of truncate the decimals. So here I'm just going to round to the hundredths place, and how I do that is using the string format method. So the arguments that are going to go in here is first the string showing kind of how I want to format it. So if you want to round this to the hundredths place, it will look like this. %, followed by 2f. And so what this 2f means is just like 2 floating points or 2 decimal points. And you could do like 1f or 1 decimal point, 3, or whatever. And then my second argument is going to be the number that I want to be formatted this way, and that's area. So let's try running this again. So now I get a cleaner looking output, and the area is 78.54 approximately, if we round it. Okay. So now let's build on this a little bit, and then rather than calculating the area, let's calculate the circumference of a circle given its radius. So let's head back to our program. I'm modifying my comment so we know what we're doing. Okay, so the same thing, we want to read in the radius as an integer, and I'm going to get rid of my area variable here and create a new one to store the circumference. Now, once again, there's two ways to do this. Number one, you can print out the integer part and then the pi symbol, or you can calculate the exact value if you multiply everything together. So first method, we just print out the integer part, and the formula for our circumference, if you're given the radius, is 2 times pi times r, the radius. So once again, we're just kind of translate this into code using the operations we know. So here, if we're excluding pi, then circumference is just going to be equal to 2 times r. And then when we print out our output, oh, sorry, it's 2 times radius. When we print out our output, it's going to look like this. Circumference plus pi. And once again, you can copy paste the symbol if you would like. So let's quickly run this and verify that it's working fine. So going back to my circle of radius 5, I would expect that my output is 10 pi. And yeah, that is correct. So now let's try the other way where we calculate the exact value, the decimal value. So my circumference is going to be a double now. And here I'm going to use math.pi again. So this is 2 pi r. And then when I print out my circumference, I can format that string. So that I have 2 decimal places and it's easier to read. Yeah, so now the circumference I get is 31.42. And so I can quickly check that. 2 times 5 times pi is 31.4159, so on. You round that, you get 31.42. Okay, nice. Now let's move on to another shape that we all know, a rectangle. So now here we want to write a program that calculates the area of a rectangle given its side lengths. Okay, so our input here is going to be a bit different. A rectangle, we all know, has 2 dimensions. We have the width, which I'm just going to call W, and then we have the length, which I'm going to call L. So then I'm going to want to read in 2 integer values, one for the width and one for the length. Okay, now I have my width and length, and what this problem is asking for is the area. So the formula for the area of a rectangle is simply width times length. So yeah, all I have to do is calculate that, and I'm going to store that in another integer variable called area. And it's going to be equal to width times length, right? And now I can say that the area of a rectangle with width this value and length this value is the area that we calculated, and we are done. That's a pretty simple program. So now let's run this. I'm going to use a simple example here. So width of 3 and then a length of 6. And for my output, I get the area of a rectangle with width 3 and length 6 is 18, which is correct. And we can try something else. Random numbers, but my output is the area of a rectangle with width 7 and length 9 is 63, and this is also correct. So our program is working fine. All right, now here, let's keep working with the rectangle, but this time we want to write a program that calculates the perimeter of a rectangle given its side lengths. All right, so let's go back to the program. So once again, we still want to read in the width and we still want to read in the length. Now, we don't want to be calculating area here. Instead, we want to calculate the perimeter, which is going to be an integer variable. And so this is going to be equal to something using the width and the length. So take a minute yourself to try and figure it out. And then let's review this. All right, were you guys able to figure it out? So let's review this. So let's look at our rectangle once again. We have the width and we have the length. And so we want to calculate the perimeter, which is basically all these lengths added together. So we know that these two parallel lines have to both be equal to the width, and these two have to both be equal to the length. So if we want to add all these together, we get W plus W plus L, which is also equal to 2 times of W plus 2 times of L. And if you want to simplify it even more, it's 2 times, and in parentheses, W plus L. So here on line 9, when we're trying to calculate our perimeter, we can exactly plug in this equation. So the perimeter is equal to 2 times width plus length. And here you have to be super careful to put these into parentheses, because if you don't, your expression is going to look like this, and Java's going to think you want 2 times the width, and then you want to add the length. It doesn't know that you want 2 times of the width and length each. So by putting them in parentheses, that indicates these two values kind of go together, and you're multiplying their sum by 2. And now we can print out our output. All right, so let's go ahead and run it, and let's test it. So a rectangle with width 5 maybe and length, 6. My output is the perimeter of a rectangle with width 5 and length 6 is 22. And you can really quickly do the math yourself. That is correct. Maybe width 9 and length 1. Then my output says that the perimeter of a rectangle with width 9 and length 1 is 20, which is also correct. Now, by now, maybe you've been wondering something, and that is, what if one of my input values is, I don't know, maybe negative or a 0 or something like that? Then my program would kind of be all wrong and wonky, right? So in that case, I wouldn't want this program to run at all if I got an invalid number for my input. So before I do the calculations, I can actually prevent this from happening. So here, after line 8, we've read our width and we've read our length. But let's say, I don't know, maybe one of them is negative or one of them is 0. We can't really have a rectangle with those side lengths, right? That doesn't exist. So previously we learned if statements, and now we're going to utilize them. So here we're going to check if the width and length are valid. And so they're only valid if they're positive. So that means width has to be greater than 0, and the length has to be greater than 0. So this is the statement for when my calculations will run. So now I'm going to flip it around to figure out when it should not run. So if the width is less than or equal to 0, or the length is less than or equal to 0, then what I'm going to do is, first of all, tell the user this rectangle doesn't exist. And then I'm going to end this program by using a return statement. So this is going to stop my entire program because I can't proceed further, right? My width and length are not correct, so there's no use going any further. So this return statement tells us stop. So now let's try running this. So let's say I got a rectangle with 0 and a length of, I don't know, 10. Then I get the correct output saying this rectangle doesn't exist and nothing else happens. Since we returned, we're not going to do these perimeter calculations and print out the other print statement. We are done. We can try something else, like -9 and, I don't know, -3. Once again, I get this rectangle doesn't exist. And this is perfectly correct. So now let's run it again with valid numbers to make sure we didn't somehow mess up our program, because sometimes that happens, and then we want to be able to catch those bugs. So yes, I still get the correct output if my width and length are both positive. So our program has worked correctly, and we're able to add an extra step to make it better. All right, now here, let's write a program that calculates the area of a triangle given its base and height. All right, so here what we want to do is read in the base as an integer and read in the height as an integer as well. So now let's review the triangle area formula for anybody who does not know it. So let's say we have some random triangle that's looking like this. So we're going to call this sort of imaginary line here the height, and we denote it with the letter H. And then we're going to call this really long base that's perpendicular to the height the base, which we denote by B. And so the area of any triangle, if you have the height and base, is equal to base times height over 2. All right, so we have the formula, and all that's left is for us to implement this in Java once again. So let's go ahead and create a variable to store the area. So here, once again, try taking a minute yourself to figure out how to write out the expression to calculate the area. All right, were you able to get it? So let's go over this expression together. So here we just want the base times height divided by 2. So here we got to be really careful to keep the product of the base and height in parentheses. Because once again, if I omit them, Java's going to think we just want the base times half of the height. It doesn't know we want half of the base times the height. So the parentheses help indicate this. Okay, now we calculate the area, and all that's left to do is print our output. So the area of a triangle base, the given base, and height, given height is, and then we're going to print out the area that we calculated. All right, now we're done. So let's run it and test it. So let's say I have a base of 8, and then I have a height of 4. So for my output, I get the area of a triangle with base 8 and height 4 is 16, and that's correct if we use the formula. Now let's try a different example. Let's say my base is 5 and my height is 7. So now what do I get? The area of a triangle with base 5 and height 7 is 17. So maybe take a few seconds, look at that output, and try and see if you can find what is wrong. Okay, were you able to find the error? So if we take a look at this triangle with base 5 and height 7, 5 times 7 divided by 2 is equal to 35 over 2, which is equal to 17.5. But what did we get here in our output? We got the area of a triangle of this triangle is 17. Okay, something is wrong here. So let's go back and review our code. We clearly have a bug. Okay, so let's start from the top. So our base is correct, our height is correct. Those are both integers. And now the issue here lies in the calculation of the area. So here, my area is an integer type. And so my base and height, their product is also an integer, right? Because they're both integers, and 2 itself is an integer. So remember what I said in maybe the first couple lessons about integer division. When we have integer division, Java basically truncates the decimal. So when I had 35 divided by 2, I got 17.5. But since the area is an integer, and here I have integer division, what I get instead is 17. Java just basically excluded this 5, and I just got 17 instead. So now we're going to fix that by typecasting, another thing that I mentioned previously. So first of all, I want to convert my area to a double instead, because I want it to store a decimal value in case I have something like 35 divided by 2. Okay, but we're not quite done yet. Once again, we still have integer division going on here, so I'm going to get the same issue. So now I'm going to typecast either my numerator or denominator. So I'm just going to typecast my numerator. And now my area should store 17.5. So let's try that again. Okay, as you can see, I am now getting the correct output. And it says the area of a triangle with base 5 and height 7 is 17.5. Okay, so did you see how we kind of approach that? So when we have a bug in our programs, we're going to start looking at it line by line and then kind of ask ourselves, okay, is there anything I could have missed here? Could I have made a mistake that could have caused this? And so that's the approach we took, and we were able to debug this program together. Okay, so now for our final exercise, we're going to do something a little bit more challenging. So here we're going to write a program that determines whether a triangle is right, acute, or obtuse, given its side lengths. Okay. And the math behind this may not be familiar to everyone, so I'll just recap it really quickly for you guys, so that all we have to do is implement it in code. So let's first take a look at a right triangle. So we have the side lengths A, B, and C. And so if a triangle is right, then A squared plus B squared equals C squared. This may be familiar to everybody through the Pythagorean theorem, which uses exactly this formula. So the sum of the squares of the two legs is equal to the square of the hypotenuse. Okay, so now let's look at the other two triangles. Let's look at an acute triangle first. So maybe I have something like this. And I'm still going to have three sides, A, B, and C. So now, if a triangle is acute, then we're still going to use the sum of the two shortest legs, and then that is going to be greater than C squared. So one really important thing to note when we're doing these comparisons is that A is less than B and B is less than C. That's how it should be ordered. Got to be really careful with that. And finally, an obtuse triangle. A, B, C. So then here you can probably guess, then A squared plus B squared is less than C squared. Okay, nice. So now let's begin by reading in our input, which are going to be the three side lengths, A, B, and C. Now, another thing we want to make sure is that they are in order. So let's try and specify that when we're asking for input. So enter three side lengths in ascending order. So our first one is going to be A. Our second one is going to be B. And our third one is going to be C. Okay, so now how can we go about determining whether this triangle is right, acute, or obtuse? Now, if statements came to your mind, then you are absolutely correct. That's what we're going to use. So let's first start with the most simple case, a right triangle. In the case of a right triangle, then A squared plus B squared equals C squared. So A times A plus B times B equals to C times C. then I can print out. This is a right triangle. Now we have basically three statements here, so I'm gonna need an else if statement, and I'm gonna figure out is this triangle acute. So in that case, a squared plus b squared is greater than c squared. And then I will print out this is an acute triangle. Finally, if my sides didn't satisfy any of these conditions, it's got to satisfy a squared plus b squared is less than c squared, right? So that's a guarantee. And let me add comments showing what triangles these are. Okay, so now I can say with certainty that this is an obtuse triangle. And there we go, we're done. So let's test this. So let's try a case for a right triangle first. So like 3, 4, 5. I get my correct output saying this is a right triangle. Then let's try something else that's random. Like 4, 2, 9. I don't know. Then if we take a look at these three equations side by side, then hopefully for output we should get obtuse. Oh, sorry, this has to be in ascending order, so that'll be 2, 4, 9. And for my output, I get this is an obtuse triangle. And let's try one more test case. And I get this is an obtuse triangle once again. Okay, so now we are done here, and hopefully you've had fun discovering some of the ways we can apply geometric concepts in Java and mathematical concepts as well. So now, thank you so much for watching this lesson, and I will see you guys next time. Bye.